So today I'm going to be going through the uses of drones in landscape architecture and landscape design professions. So drones are established in two separate fields, main fields. One is art, which is purely visual. It's more about photos and video. Then the other is science, where it's data-driven, where it's fields such as research, analysis, engineering, mining, and forestry. In landscape architecture, really benefits from the use of drones because it is the incorporation of both art and science to provide an informed design solution for outdoor environments. So it really benefits from the integration of drones into our profession. So currently there is a lot of software that landscape architects use, such as Photoshop, Rhino, and AutoCAD that can be used with drones. So we already have a lot of the infrastructure to use drones. And then with the incorporation of third-party softwares such as Drone Deploy, Pix4D, or Maps Made Easy, which use some of the more technical GPS capabilities of a drone to provide really accurate and useful data that landscape architects and designers can use. So the first use that is the most obvious with these camera drones that have really high-resolution cameras is, of course, photography. So you can take really high-end, high-resolution professional quality photos with a drone. And this isn't just for taking pretty pictures of a built project, it's also for analysis. You can take a picture of a site, you can get a better understanding, so not just from the ground view, but also from an aerial view. And then you can use it from all the way through till construction administration, monitoring how a site's being built, then also to presenting the project like this photo here, which is a built, finished project. And one example of how to use drone photography in the presentation for a project would be to make before and after renderings. So here's an example of the photo on the left is just the aerial photo from a vacant site in San Francisco. And then if you note down the elevation that photo is taken, the distortion on the lens, you can match that view perfectly in 3D modeling to then overlay your 3D model and then Photoshop over it. So you get a really nice 3D rendering that has all the accurate context and is really effective way to present a project that connects the client. Here's some examples of that for a project I worked on for my ASLA award. Here are two examples. So on the left photo is a before picture, and then I overlaid the 3D model, did some Photoshop, and then got a really nice rendering on the right side. And another capability that the drone has that takes really high quality video. Most of the drones now take 4K video, and you can do something like do a video tour of a site. So you could fly throughout the site looking at different objects and narrating over it, saying, here's this and that, and then you can send that to your teammates, your client, to really get a better understanding of the site. And you can even do this in real time by live streaming video. So you could even be on a phone call while you're flying the drone, and people can ask you what to look at and all that. So it's a really exciting opportunity for collaboration between fields. So to even take that further, I'm foreseeing in the future that all drones will be capable of taking 360-degree photos. And this is essentially a camera that can photograph everything around it. And I have an example of a video that I took here. So this is a 360 camera strapped on the bottom of a drone. This is very primitive for now, but I imagine this being much more advanced in the future. So this is the drone looking up, and then it flying throughout a site. So this would be a great tool to get a better site understanding and even do site tours remotely, or even present. In the future, I can imagine you could superimpose a 3D model rendering over stuff like this. So it's a really exciting feature that drones have. And then you can also take really high-resolution 360 photos. Here's a photo on the Embarcadero. Kind of distorted incredibly, but here are some... here it is on Google Earth. So I've uploaded these to Google Maps, and anyone can view them. It's kind of like a street view, and you can just look around 360 degrees. You can even look in these in virtual reality, get a really nice understanding, and you can zoom in and get little snapshots of different spaces. So this instead of framing your shot when you're going to do photography or site inventory, site documentation, you can just take a whole shot, get everything. And if you miss something, you can go back and reframe it. Like you can count how many trees there are or whatever. So another possibility for this and going into virtual reality is that you can take one of these 360 photos and then Photoshop over it and get a 360-degree Photoshop rendering that can then be sent to a client or a team member to be viewed. It's just a more immersive way to present a project as opposed to like a framed rendering. So that's a really exciting new thing. And that's not just for drones. You can do that with any project. So that was kind of the artistic side of how drones can be used in landscape architecture. Now I'm going to go into more of the scientific, more data-driven, practical uses. So here's a really crude way to make a map is to take a series of photos looking straight down and then Photoshop them together. Then you can trace through in AutoCAD and create a really quick map of the site. So this would be useful for spaces where maybe Google Earth imagery isn't current or it's not of high enough quality where you can trace. The drone imagery is much higher resolution than standard Google Earth imagery. And to take that even further, with the use of these third-party softwares which utilize the GPS capabilities of the drone, it can make really high-quality survey-level 3D models and topographic surveys and other data that I'll be going through here. So what the drone does is it takes a flight path throughout the site that you designate. You circle out an area, and it will use photogrammetry, which is a photographic technique to create 3D models and orthomosaic maps. So it works how your eyes work. You have stereoscopic vision. So imagine you have two eyes and you can see depth, but multiply that by hundreds or thousands of photos, and you can create a 3D model of a space. And this is a very old technique, and it's been used for many years, but with the drone, it's become accessible to anybody who can have a drone. And here's an example of the resolution for a Google Earth image, which is fairly grainy on the left, and then a drone image, which is much more clear and precise. Google satellite views are typically 30 to 50 centimeters per pixel, so every pixel in an image is about 30 to 50 centimeters, whereas a drone it's 1 to 5, depending on your altitude. And here's a really cool example of how you can use a drone map to monitor a site throughout the seasons. So this is, on the left, it's a photo in June, so early summer, and then photo in fall, and then a photo in winter. So you can kind of understand the actual seasonal progressions of a site. And this would have many other applications for monitoring erosion, tree health, forestry. I mean, the possibilities are kind of endless for this application. And with the software, you can map the same route and duplicate the exact same flight path. And that's what I did here. So I just duplicated the path and exported a map. So with the future of machine learning, artificial intelligence, and how that's going to be augmenting our design process, software such as this, which is an artificial intelligent tree counter. So it will work with this 3D software or the 3D map, and it will actually count the trees that are living and dead or deciduous. And this is a beta software. It's in development now, and I used it on a site, and I was able to count in this area there's roughly 1,400 trees, and there's 11 deciduous. So in this example, you'd be able to pick out where these dead trees are, maybe remove them, replace them, and then you can maybe find infestations, stuff like that. So this is a really useful tool, and it's exciting, and it's exciting to see what the future holds for artificial intelligence, especially in our field. So here is an example also of NDVI mapping, which is normal differentiation vegetation indexing, where it actually signifies the plant health based on the chlorophyll, the amount of green in the leaves. So that drone software also exports this data set for you to use. So this would be useful if you're mapping out a large area. Maybe you could monitor the plant health of a species, or in this case, I mapped out a portion of the Russian River and was able to signify where an invasive species, Arundodonax, was habitable. So in my thesis project, I could say that we could eradicate in these areas for habitat restoration. So here we got the 3D model, which is using that photogrammetry, it's able to create a 3D representation of the site that's it's actually very accurate. If it's bare earth, if there's vegetation, it actually maps the vegetation as a solid, which is the limitation of photogrammetry. So this is my project site that I worked on, and it is a gravel mine, so it's a perfect case for the use of this drone scanning. And what you can do with this drone is you can even 3D print the site. So here's an example of a 3D print of a site that was drone scanned, and you can print these out to scale, and it's a great way to study the site. This is just one example of how to use it, and you can even walk around through them in 3D softwares, and it's really cool. And with that 3D model, you can extract topographic lines, so you can cut them horizontally and then get a fairly accurate topographic map, which is great for understanding the slope and the grading and drainage of a site. So here's an example of the orthomosaic map that you get with a drone, and then a topographic map next to it. And you can see where the trees aren't, it would be a very useful and accurate topographic survey. So with that 3D model, there's a lot of things you can do with measurements, and measuring the heights of things, and also measuring the volume of certain elements. So in this case, I was able to measure this pile of gravel on the left in the blue, and saying it's 2,000 cubic yards, and you could also measure this negative space on the right, and say if I wanted to fill that, I would need roughly 20,000 cubic yards. So for a landscape architect, this would be a really useful way to budget for the removal and grading of a site where you need to cut and fill in certain situations. This could become really useful because calculating organic volumes can be somewhat difficult. So here's a case study of how I actually used a drone for a project site. So this was a site in Forestville in Northern California. It was a 4-acre site. The client was on a budget. They didn't have a site survey or a base map of any kind, so we were just working with what they had as a property. So I thought this would be a perfect time to actually use a drone, and it was actually a perfect candidate because there's deciduous trees, so that it could actually 3D map everything. So I went there, I mapped it out. It took about 5 minutes to fly the drone throughout the site of 4 acres, so that saves a lot of time as opposed to me going out there and manually measuring everything. I did take several measurements in the corners of the property to make sure that the output and the end of the map was accurate. Then here's an example of the 3D model that was exported. And you can look around and kind of explore this site. And the great thing about this is that it's an encapsulation of the site in that period and that time, so you know what was there, you know what the measurements are, and you don't have to go back and, if you miss something on a site visit, you don't have to go back and measure it. You got this one thing and it's done. So it's a great tool for documenting a site, and you can do multiple maps at different times. Going back to here. Then here's an example of doing the topographic extractions from the model. You go into Rhino and you can do contour cut from the model. So it was really surprising for the client for this project was how much of a grade change there was from one corner of the site to the other. So from the top corner, there's about a 20-foot grade change. So that was something that was really insightful for us for the project, and it helped us alleviate some drainage problems that they were having. So without the drone, that would have been fairly difficult to do for the budget that they had. So here's the orthomosaic map on the left, which is the plan view, just aerial imagery. And it's with that and the 3D model topography, you can create a fairly accurate survey, which is very useful for the purposes of this design project. So here's just some examples of the design studies we did based on this map. And with that 3D model, we were able to extract all these vertical angle and all these measurements that otherwise you would have spent a lot of time, wasted time just measuring the building for the context. But with the model, we were able to extract all these measurements and fairly quickly get a SketchUp model built from these reference measurements. So as this technology that we have with drones increases and further advances, I think it's very important for us landscape architects to get engaged with them and use them and educate ourselves, because other fields are using them. It's changing and it's disrupting many other fields. And landscape architects, as I mentioned before, because we're an art and science-based profession, we uniquely benefit from the incorporation of this technology. And I think all of you should go out and experiment somehow with it, take the drone class, buy yourself a toy drone, practice with it, and then eventually get a drone yourself. And it's a great way to possibly get hired for a project or gain contacts in the profession. So thank you very much, and I hope this inspires you to learn more about drone-aided design. Any questions?
Can you go back like 2 or 3 slides to that one? Oh yeah, that one. So you created the digital rendering out of the drone model. Yeah. And was that done in Photoshop?
So this model here is a 3D, it's an OBJ model, which is a standard 3D model format, which is the output from the drone software. So I opened that in Rhino and was able to take reference measurements. So I was able to measure the roof line, the angle of the roof, the angles of the width and size of these slats on the side of the house. Everything I was able to measure, even the heights of some of the trees. So it was a great way to then translate it into SketchUp, which is a much cleaner 3D format that's more malleable for my purposes for the design.
And did you go out and just field check any of them, just to kind of, like, that would be my anxiety, is that it says it's 30 feet, but it turns out it's not.
So I took about 3 measurements on this base plan here. So I went to the corner and measured the width of this greenhouse. I measured the pool, because I knew that was something that I could clearly see from the aerial photo. It wouldn't be disrupted by tree lines or anything. And then I measured the width of the driveway in the front. So then I was able to confirm that these were all accurate when I got the eventual output of the digital model.
And if it's off, can you scale the model so that you can make it right?
And sometimes with the software, it's fairly new, so I've noticed that some of the models that I got have been distorted, but in the case of this one, it came out perfect. And I even I ended up finding a LiDAR survey of the property after the fact that I did this, but it ended up being an almost exact comparison to this contour map, which was relieving.
So in that AutoCAD base, the contours could either be from the drone, but all the rest of the drawing you're tracing in on top of the.
Yes, correct.
Right.
Yeah.
And do you do anything to the photo? I mean, do you turn it to black and white and try and before you do your tracing, or how do you make sure it's like, because you're tracing over a photograph essentially.
Yeah. So I just overlaid it in AutoCAD, faded it out so I could see through it, so it's transparent, and then traced over it. So it's as simple as that.
Interesting. And you've been doing some consulting for other landscape architects as well, right?
I did some drone photography for CMG, and that was primarily it. Mostly just for photography, because they wanted an aerial view of a project.
Okay. Interesting. Any question?
I'm actually taking the drone class right now. And they basically take it more in the space of the film and all that.
Yeah.
And sorry I'm late. Sorry I was late, but I was really interested about this. But which drone would you recommend us to buy for the future, like for the landscape?
Well, every year it's going to change, because now they're coming out like iPhones, where they update every year. But of course, DJI right now is the premier manufacturer of drones. So either a DJI Mavic, which is what I have right here, it's compact, it folds up in size, and it's got a really powerful camera. I mean, it's 20 megapixels, Hasselblad. You have a lot of control. I mean, for landscape architects, it's more than enough. This is a professional photography
I saw the
camera.
Mavic Air. Is it good too? Like it's smaller, but
I would recommend the
Pro?
the Pro.
Okay.
It has a better range, which for some projects might be more important, so you can fly further without losing signal. But for school, I think it would be great to get the Mavic Air.
Okay.
So with projects, say a public project which needs to have a little more documentation, say a formal survey, how do you reconcile drone data with survey data?
So I would call this data as supplemental. Like in the meantime, while you're waiting for a site survey and you want to start designing a project, you can use this to get fairly accurate data really quickly and at a really small fraction of the price of a survey. So that would be where I think it fits in. It has no way will it ever replace a site survey, of course, because those are legal descriptions of the land, but this is a great way to get supplemental information in the meantime.
Well, it could be that there's more information than you have on a survey.
Yeah, well, in some cases that would be the case. And a lot of surveyors actually are using drones now, so it's becoming a standard in the profession.
So do you correlate with GIS in terms of...
You absolutely can. You can have everything geo-referenced. All the photos that the drone takes are geolocated, so they have geotags on them, so you'll know exactly where the photo was taken on GPS coordinates. That's how it's able to make those really accurate drone maps.
Eric, you may want to tell the story that the letter we got from the surveyor.
Yeah, so I did this presentation to a drone expo in San Francisco about 2 years ago, or a year and a half ago, and it went great. And then after a few months, we got a letter in the mail at Antonio Buffalo Landscape Architects to get almost a cease and desist letter, because they thought that we were claiming that we were doing site surveys, but we're not doing site surveys.
We weren't licensed.
You're not licensed surveyors. So they assumed that we were taking the spot of a surveyor, but we were just using this as an in-house design tool for us to understand the site. So we're never giving them like this plan, like saying this is a site survey. It's just for our purposes. So engineers know it's a disruptive technology, and they're just protecting their profession as they should. So be careful when you're using this data.
We had to write a letter to
California.
The state of California, same division we're in for licensing, but it was those guys licensed surveyor,
Yeah.
and we stated, and we had to use the right words to say, like supplemental, and we tied it into the fact that we were using it to prepare 3D renderings. So we kind of tweaked it that way. And then we finally got a letter back several months later saying that we were exonerated.
And also, on another note of professionalism for drones, you have to be you have to get an FAA license to fly professionally. So if you're going to take photos and get any profit from it for any reason, or if you're going to take photos for marketing for your own projects, you technically have to be a licensed drone photographer. So I did get my drone license. It's quite a bit of studying. You have to learn a lot about FAA regulations. It's more about them understanding that, or more about you understanding that you know that airplanes have flight paths and you cannot fly within their flight path. And if you do, you know what to do. So they don't care how you fly the drone as long as you don't fly it in their space or over people or all these other things. So if you do fly a drone, be very cautious of the regulations and guidelines.
Well, there are maps And when I was looking at a map, because I wanted Eric to come and actually fly a drone off of the cannery, and we'd see it. And the problem was the other side of the cannery, the hotel, is actually federal land. It's the end of the GGNRA. And then there's this helicopter. There was some kind of a helicopter thing where they were basically saying
Alcatraz.
almost anywhere in San Francisco they didn't really want you to do it because...
Well, with an FAA Part 107, which is what I have, you can fly within helicopter airspace. Within Class B airspace like San Francisco, you cannot. You have to get permission, and they're changing the regulations every month. I mean, the government's, because this is a new field and new technology, so the government's slow to catch up, so they're catching up. And they're making it easier for us to get permission to fly in airspace. They have apps for it now that you can call, and you could fly within Class B airspace if you are given permission. You have to call the actual air traffic tower and say, I'm going to fly my drone 200 feet above the ground, which is kind of funny. But
So do you do like barrel rolls and things like that with
no,
this?
this drone's like, it's just rock steady. It's got GPS coordinates, and it just floats there.
Yeah.
I mean, you could push it yourself, and it would just come back to the same spot.
Okay. You can't
This
just
isn't a
switch off the autopilot and, make some wild videos.
not with this one. They've handicapped this a little bit. I'm sure if you hacked it yourself, you could go crazy.
I was wondering if you could talk a little bit more about the sort of adjacent technologies, the VR. There was a presentation you did for one of our open studios where, and this may or may not be related to the drone, but you had some scanning 3D scanner you could put on your iPhone and scan a person, and then they get uploaded into the model. And I'm just wondering, sort of in terms of what's possible, but also sort of what's practical, like,
Yeah, that was a portable 3D infrared scanner that I have, where you can scan small objects about 5 feet to 20 feet. It's just, I really love technology, and I like being involved in the newest technology, so this is something that probably will become very commonplace, that everyone will be able to 3D scan anything they want, and phones already have the capability to do it with photogrammetry, which all those 3D scanning apps, if you ever played around on your phone, they have some. But yeah, I just brought that so I could show people all these new technologies, and it's similar to how the drone scans things, so I thought it belonged in this lesson. Yeah, you could pass these around if you guys want to see all these 3D things.
And do you know if more landscape architecture firms are buying drones?
Oh, yeah,
or if they're doing consultants? Or
It's
how are
becoming
they
very
doing it?
commonplace for many firms. Ones I know have drones are SWA, has a few drone photographers. Rio's Hail Clemente, I know, has a drone. I think a lot of them have drones by now. It's just becoming commonplace. So it's becoming like a tool, like you have a tape measure, you bring a drone. It's becoming just as, because it's so easy to fly, they're very safe, so you don't have to worry about your investment falling out of the sky, because these things are very reliable.
What sort of range do these drones have?
As far as distance,
Distance and time, yeah.
so that's always improving with time. Right now, this one right here can fly about 5 miles. On a perfect clear day, with visual line of sight, you can fly at 5 miles, the range of that, and then you get live streaming feedback of very clear 1080p video footage, so you can see what it's seeing in real time for about 5 miles away, which is incredible. And I never could imagine doing that. And it's about 30 minutes of flight time.
What if you have a windy site? What are the parameters for that?
These fly about 40 miles an hour tops, so 40 mile an hour wind, you're going to be able to stay steady. Yeah. So yeah, general rule of thumb is you fly on a clear, calm day.
So, but with the wind, you'd be flying like this, right?
Yep, it'll tilt up, but the camera has a gimbal on it that adjusts, and it is always steady. So even if the drone's tilted like that, the camera's going to be flat level.
the last thing I had was we had talked at one point about how there's a software inside the drone that's how does this working? Is it sending it to a satellite that then goes back to your computer?
So you're talking about the drone scanning software?
Well, yeah, what's inside there, and that there were issues at one point about. So you had said one of the ways, because I've had students try and drone map Baker Beach, but there's like this invisible wall where the drone will not go because it's already programmed in, I guess, that federal lands.
Geofencing?
Yeah, geofencing that you can't. So somehow they've already got that in there, so you can't just like fly it over federal lands necessarily. I don't know if you know about sort of what's happening inside there, but I just thought that was kind of an interesting part of it.
I'd have to advise against flying in federal airspace, but
right. But you
there is a way to turn it off, but don't.
Yeah, I know. You're not going to tell us.
Yeah, I know how. But, yeah, it's called geofencing, where the manufacturer of the drones, in order to get on the good side of the FAA, they've done it, and they've pre-programmed the drones to not fly within certain airspaces. Because DJI's got a lot of problems with the U.S. government because of espionage and spying. They've been noted to be giving the Chinese government some important information. Because the military actually used these in combat zones, and then they ended up getting compromised because they could be easily hacked and all the information could be leaked. So they're trying to play good guys. But for the for the 3D scanning, what happens is that the software is running on your phone, and it's telling the drone where to go from your phone through the remote. So it's doing the flight path and taking the photos, and then the photos are then you can upload them from the SD card in the drone on your computer, and then that's where the processing of the map takes place. They're working on live map making, so it actually does it on the computer of the drone. So that's already possible. I haven't tried it yet.
And you had said there are also cloud-based software.
It's a cloud-based software.
Right, that it live feeds into that and can start building the model and all of that.
Yeah, so you have to upload it from your computer or your phone, and it will just do it on the cloud. Because the cloud, they have processors on their computers on their network that are more powerful than I'm sure what most people have on theirs, so they can do it faster.
So how does the communication work between your phone and the drone? It's not Wi-Fi because it goes beyond the range.
It's our remote control, so it's got I think I got it over here. It's a little remote here. It just has antennas that has a really good range.
Cool.
And you plug the phone into that so you can see the live stream on your screen.
So the phone is acting as the camera, but that thing is actually what's connecting to the remote is what's
Well, the camera's on the
to
drone itself. This is a screen.
Right, but I mean it's the screen that you're viewing it from.
Yeah.
Yeah, right.
And you can fly without the phone, but then you won't be able to see what the drone's seeing. So.
Okay. And have you experimented much with creating 3D or VR model space that you can then walk around in and?
Yeah, I mean this 3D model right here, you can open in virtual reality. I mean you could walk around this probably in an Oculus Rift or something. Even with this guy here, you could explore it. Here's some other 3D models. These are all to scale, so you can go down and like this cul-de-sac here at eye level and walk around. Yeah, and then here's here's an example of a map where each one of these rectangles is an image, and then it's compiled all those together to make this map right here. And it's overlaid over existing satellite imagery, which you can see the quality difference. It's quite amazing.
Questions? Does anybody else have any questions?
Yeah, that's Ridgeline. It's well documented.
Yeah.
That's for sure.
Anybody else? All right. Well, great.
Yeah, So you talk about the aerial photograph on the first, and how do you combine it with a model that after you build a model, you set the same angle
go
and then
back to
put them
that.
together? Yeah, this one.
So this one. So what you do when you take a photograph in the drone, I mentioned it's geolocated, so it will say the elevation above sea level that the drone photo is taken.
Yeah.
So you need to mark that in the 3D model. So you go. So say this one's about 400 feet above sea level. In the 3D model, you go 400 feet above where you're.
You said the same.
You set the same view in the model, and then you can overlay it. But the important thing to note is that you have to get the lens distortion on the camera. So for this one, I think the lens was a 34 millimeter. So then you get the distortion to match perfectly. Then you just overlay the two images in Photoshop, and then make it look pretty.
Oh,
Yeah.
thanks. Looks cool.
Thank you.
Just make it look pretty.
Yeah,
Yeah.
that's what the Photoshop comes in.
Yeah. All right. Do you have any concluding thoughts or anything?
I just think if you guys are excited by this, definitely go out and experiment with it, research it, and try to incorporate it into your student projects. I think it's a great tool for all the way from design through till presentation. So, yeah, go and try it out.
All right. Well, thank you for coming, and thank all of you for coming.